welcome to Deeksha Vedantu. We are back with another episode in our OG series that we started to ace our class 10th boards in 2027. Now this lecture is very important because it is the very first chapter of your class 10th science overall as well as your chemistry, and we are going to try to quickly revise this in 30 minutes. Okay, now how many of you love tea, chai? We call it, right? So, and obviously a lot of you might love chai, but how many of you know how to make chai? A lot of you who do know may know that we combine a lot of ingredients, that is our tea leaves, water, milk, and if you are an OG chai paglu, you must add adrak in your chai as well, right? So all these ingredients, when are added, they form a product. That's our final product, the chai. Right? Now that chai is our product, all the ingredients that we combined are our reactants, and this whole situation is called a reaction, which is exactly what we are going to study in this whole lecture and today as well. Right? Now this equation part is what science gave us, so we'll look into all of that. Right? Let's understand it from a bit of a scientific view, right? So chemical reaction is simply a process in which one or more substances, milk, water, adrak, chai patti, is added. These substances changes or transforms into a new compound, that is your chai, and this whole thing is called a chemical reaction, and this chai has new properties as compared to alone milk and water and tea leaves, right? So this whole process is called chemical reaction. This only rearrangement of atoms take place in this chemical reaction. Of course, we know that some of the atoms were arranged in tea leaves are different than the atoms arranged in the final tea, right? So in chemical reaction, rearrangement of atoms occur. Right? The substances which combine or react are called reactants, and the substances which are produced, that is our tea, is called our product. Now let's see a very common reaction in chemistry, right? So you take Zn, that is your zinc, you combine it with sulfuric acid, H2SO4. So zinc plus sulfuric acid. So this part on the left hand side is called your reactant. On the right hand side, see it now. Zinc is combined with SO4. So here zinc was alone. Now we got someone. So this is ZnSO4 plus H2, that is your product. Great. Understood everyone? Very simple. Now, moving on, the next thing we have characteristics of chemical reactions. Now, whenever we combine some of the compounds, see when we combine milk and water, we give it heat as well, and it gets so heated up, so atoms get rearranged. So similarly, sometimes the reaction will result into heat, sometimes it will become cold, sometimes it will change the colors. So all these things are characteristics of chemical reactions, right? So the first, evolution of gas. See, when we saw Zn combined with H2SO4, it gave ZnSO4 plus it gave us hydrogen gas as well. So hydrogen gas is evolved from this reaction. That is why we call it evolution of gas. Right? Then formation of precipitate. What is precipitate? Precipitate is something that settles down, that precipitates. Okay, so something, when you put something, let's say when you make chai, the chai patti is left behind in our whole vessel, right? So we filter it out. So that chai patti that we do not drink is called precipitate, right? So in the reaction of precipitation, we have PbNO3 twice. How do you say it? PbNO3 twice. If you write twice, that means the whole bracket is with NO3. So PbNO3 twice plus Ki, potassium and iodine, potassium iodide. When you combine them, they become, now iodine is so much stronger, right? So it replaces NO3 as like hut. So NO3 like flies away and iodine takes its place. So it becomes PbI2 plus KNO3, and this PbI2 becomes our precipitate. What we say? Iodine is very, very strong. Okay, so it kicks NO3 away and combines with lead, but lead and iodide, that is lead iodide, it settles down, that is it becomes precipitates. Okay, then change in color. Now CuSO4 plus iron. Now copper sulfate is actually brownish in color. This copper sulfate is actually brownish in color, but iron we know it's greenish in color, right? So when they combine, FeSO4 becomes, that is FeSO4 is green in color. So now here color is changing from brown, it is changing to green. Right? So change of color happens. Change in temperature. CaO, calcium oxide, when you put it with water, like calcium oxide is the same that we like paint our wall, we call it tuna. So CaO, when you put water in it, it's like it gives so many flames out, so many fumes out, it gets very hot around it. So CaO, when combined with water, it gives CaOH twice, but along with that it gives so much heat, that was a fire emoji, but it changes the temperature. Okay, now beta, the last is change in state, that means the state changes. So when you burn a candle, the candle is changed, it gets fumes are coming out of the candle and the whole candle just flies away, it gets gayab, it evaporates in the atmosphere. So change in state also happens. Or you can talk about naphthalene balls. So naphthalene balls are solid. So solid, when you keep it out for a few like days in the atmosphere, it all gets evaporated. So it changed from solid to directly gas, that is change of state happened. So understood? Sometimes some of the characteristics of these equations are evolution of gas, formation of precipitate, change in color, change in temperature, change in state. Will you learn this? Right? Beta, you can learn this, right? Evolution of gas, precipitation, change in color, change in temperature, change in state. 5 things you have to remember. Okay. Next we have how to, like, what are chemical equations? We studied about reactions, but what are chemical equations? Now, if you write down that I mixed water and milk and tea leaves and adrak and it made chai, that is equal to chai, then that whole thing you wrote is a chemical equation and that's it. It is a shorthand method of representing a chemical reaction using symbols. Chemical reaction was making of chai using symbols and formula of the substances involved. Done. Now there are 2 kinds of equation. Word equation is that you directly wrote chai plus water and all that stuff and you say chai is made, right? So similarly in chemistry, what we write? Zinc plus sulfuric acid equals to zinc sulfate plus hydrogen. Right? Now we talk about symbols in chemistry. We know there is a periodic table. We know every of the element has a symbol associated to it. So zinc has Zn. So instead of zinc, I can write Zn to like make the process faster. Plus sulfuric acid. We know there is a formula of sulfuric acid as well. That is H2SO4. Right? Now if these combine and equal to now ZnSO4 plus hydrogen is simply H2. Understood? If you do not write the full names of the formulas or the acids or the elements, you write their symbols and formulas, that become a chemical equation in chemistry. Right? Now, one very important thing, the physical state. How do you know that zinc is a gas or zinc is a solid or H2SO4 is a liquid or a solid or a gas, and then the product became our what? So we define it with a bracket among them. So instead of just writing Zn, we write Zn and in bracket we write S. S means solid. H2SO4 is always liquid form. So you can either write L or you can write aqueous. AQ means aqueous, you know water means aqua, right? So from that, if anything is liquidy, we write AQ, that is aqueous. Then the product form is ZnSO4, that is also in aqueous form. See, how do I know ZnSO4 is aqueous? Practice. I have been studying science from so much time that I just know that ZnSO4 will become an aqueous solution, and that is why you have to practice as well. Okay? Now you know why do I have to practice beta, है ना? Okay, so H2, now H2 become, H2 is hydrogen, is obviously we know it's a gas. So these reactants and products can be represented by using the symbols like solid, like liquid, like aqueous, like gas. For liquid, for L for liquid, AQ for aqueous solutions. Done? Okay, moving on, we have to study about balancing of chemical equations. I know I used to dread this part, clearly, like literally when I was in class, and whenever they asked me to balance an equation, I just used to cram it and go, and I'm like, ma'am, I don't know. I know there is a 4 here, but I don't know why. So, but then, of course, I did graduation and all that stuff vanished out. I understood I had amazing teachers, and I hope you consider me as an amazing teacher as well, because I am going to tell you how to balance the chemical reaction as well, equations as well, okay? Now, first of all, just write the unbalanced equation. Whatever you know, just write the unbalanced equation. KClO3. It decomposes. We'll study what decomposes means. It decomposes into KCl plus O2. Now, what you have to do, first you have to see, are the elements on both of the sides, are they actually unbalanced, or I'm just stressing about nothing, right? When I don't get a text from there, right? Right? Okay, so KClO3 is decomposes into KCl plus O2. K is 1 here, K is 1 here. Okay, that works. Cl is 1 here, Cl is 1 here. That is completely sorted out. O is 3 times here, but O is only 2 here. So, first what we are going to do, we are going to make this very, very easy. Let me just show you how to do it, then I'll get back to the notes. So, what was our reaction? KClO3 gives KCl plus O2. Done. Now, K is 1 here as well. K is 1 here as well. 1 here as well. Cl is 1 here on the reactant side, 1 here on the product side. O is 3 on the reactant side and 2 on the product side. So, we have written what is the problem here, right? Now, if I want to make these both equal, what should I do? I should multiply 3 with 2 and 2 with 3. This will become 6 and this will also become 6. So, the both of these things balances out, right? But there are some rules you have to follow while balancing these, right? Now, KClO3 gives KCl plus O2. Now, what you can't do is multiply 3 here, O2 into 3, and you think this becomes O6. That is wrong. O2 is nature's decision. Okay, what you can do instead, there is O2 here, right? O2. You cannot multiply on the foot. This is what we call a subscript. So you cannot multiply in the subscript. However, you can multiply in the front of this. So here you can multiply 3. So O here is what now? 3, multiply it by 2. 3 into 2, 6. But you don't write 6. You write it like this only, 3O2. This will be your final answer, the balanced answer. Okay, now I multiply this here, but I also have to multiply here. Now what I can't do is, I cannot multiply 3 into 2. This is prohibited by nature, right? So what I will do, now you cannot multiply here as well, because this whole is one compound. This whole is a single compound. So you cannot like put 2 inside anywhere. You have to write the 2 in front. That means here, now 2 into 3, oxygen becomes 6. Oxygen here becomes 6. But in making the oxygen equal, we did a mistake that K and Cl also got 2 here. Now see what is this. KClO. K is 2 here now. K is 2, but here K is 1. Cl is 2, but here Cl is 1. Now O is 2 into 3, 6, and O is 3 into 6. So O is like, I am done, you see yourself. Right? But beta, we have to look for everyone, right? K and Cl are dependent on us to be balanced. So we have to study about them, right? So what we'll do, if I just multiply 2 here as well. So what happens now? Now K here is 2, K here is 2 as well. Now Cl here is 2, Cl here is 2 as well. O here is 6, O here is 6 as well. Understood? Understood. Any doubt you can write in the comment section. But I hope, my beta, this is clear to you, right? So this whole process is how you balance chemical equations, right? Now see what they are asking us to do. Write the unbalanced equation. We wrote the unbalanced equation. Then they're asking count the number of atoms of each element on both sides. That we did, right? We counted the number of atoms of both the elements on both sides, reactant and product side. Then we have to balance them. Now multiply the symbols and formula by the smallest number to balance the reaction. Now multiplying 3 with 1 is simply 3. So the next smallest is 2. So we multiplied 3 with 2, 2 with 3, and then they are balanced. Understood? Now one more thing is, ensure the coefficients are in the simplest whole number. That means, let's say KClO3 equals to KCl plus O2 is there, right? I can also write 3 into let's say 3 into 2. So I can also write like this, right? 4 into 3 will be 12 and 6 into 2 will also be 12. So this is also balanced, and this I will write 4. So K is 4, Cl is 4, K is 4, Cl is 4, 4 into 3, O is 12, 6 into 2, O is 12, right? Still they are balanced, but they can be divided down, right? You can divide this 2 by 2, this 4 by 2, and this 6 by 2 also. It will become 3. So the actual should be the smallest whole number is the simplest, you can say, or the smallest whole number. 2 is smallest and 2 works, so we will use 2. Then 4 is not the smallest, then so we will not work with 4. 6 is not the smallest, 3 is the smallest, and 3 works. So we will go with the simplest or the smallest whole number while balancing the chemical equation. Then we can do with 4 as well, but that will not be the correct answer. The correct answer will be 2 and 3. Then okay, understood. Very good. Now we have to see the types of chemical reactions. How many of you dread this part? What are the chemical reactions, ma'am? I don't remember those. Do you? Okay, let's make it simple today, beta. I am here. Your Aditi Ma'am is here. Do not worry at all. Okay, so the very first is in tea. You are doing what? You are combining lots of ingredients. That becomes combination reaction. Combination of 2 or more ingredients is called combination of reaction. What is the example given? If you combine hydrogen and oxygen, it becomes water, and this is balanced. So 2H2 plus O2 gives 2H2O. So the H2 and O2 combined and they form water. Understood? Displacement reaction. Displacement means in Hindi we say खिसकना, right? Or we can say that to move from that place is called displacement, right? Now displacement is, see very carefully, Zn plus CuSO4. Now product is ZnSO4. That means Zn displaced copper. Zn said the copper hai nikal. So copper left, tata bye bye, and then I will take your place. So Zn took the place of copper, and copper sulfate was converted into zinc sulfate, and hence Zn displaced copper. Zn displaced copper, and hence the reaction is called displacement reaction. Understood? Now double displacement. Now these are like, okay, something wrong happened with copper, some Zn came and he threw it out. So we will have to do something else. So Na2SO4 is there and BaCl2 is there. So Na2SO4 is like, hey Ba, I want to be with Cl, so go away from here. But Ba is like, no, I want proper share of me, right? So Na is like, okay, I will go with Cl, you go with SO4. So Na goes with Cl, making salt, that is NaCl, and Ba is like, okay, SO4 is free now, I'll just go to SF4. So it becomes BaSO4, and we just study BaSO4 is an example of precipitation reaction as well. So see, Na displaced Ba, but in turn Ba also displaced Na. So it's double displacement. Here only zinc displaced copper, so single. That is displacement reaction. Here both of them displaced each other. Both of them took place of each other. So it's called double displacement reaction. Understood? Next we have decomposition. Now combination is combination of these two. Decomposition means to get decomposed. You say that the body of that animal gets decomposed, so it breaks down. Decomposition means breaking of one reactant into two or more products, and that is called decomposition reaction. Just like this, CaCO3, it breaks down into CaO, calcium oxide, plus carbon dioxide. So one CaCO3 gave carbon dioxide and calcium oxide, so product is more than one, reactant is simply one, so it decomposes. So we say calcium carbonate decomposes into calcium oxide and carbon dioxide. Understood? Next we have, what are the types of decomposition reaction? In decomposition, see, decomposition reaction, something breaks, so energy gets released when something breaks, right? And that is what energy is released in different kind of ways. First is thermal decomposition, that is heat is released, or would you say oxygen is released. So KClO3, so it breaks into 2KCl plus 3O2, that is called thermal decomposition. Thermal is heat, so thermal decomposition means heat is released. So in this reaction, 2KClO3 breaks into 2KCl plus O3, that means 3O2, sorry. So this is a thermal decomposition reaction. Next is electrolysis. So when you have to see, breaking water is a big thing. See, you know, the countries like Dubai and Iran, near that area, all of those companies uses, they don't have any water source. So what they do, they take water from sea, they purify itself, right? So they do not they break the water into hydrogen and oxygen to use hydrogen and oxygen in their further processes. Okay, so because this is actually a fuel, this is a gas, right? It can be used in making stuff and doing stuff. So they take hydrogen, they do its electrolysis. Electrolysis is you put a positive charge cathode and anode. You say, do you know what cathode and anode is? I hope you do. So there is a road and all the positive charges are there. There is a road, another, that is a negative charges are there. They are dipped into water, and you will see that charges transfer occur. H2 gets deposited on cathode, O2 gets deposited on anode, and that's how they separate the water, right? So that is electrolysis. And photolysis, AgBr, it breaks into Ag and Br. That is very simple. Okay, next we have oxidation. Oxidation means oxygen is gained or hydrogen is released. So C plus O2, oxygen is gained, oxygen is combined with carbon, right? So that is oxidation. Now whatever the oxidation happens, that agent, this O2 will be called reducing agent. Why? Because it gained oxygen, right? But the carbon dioxide gained oxygen, but the hydrogen is not released. In here you will say electron are released. Okay, let me tell you one thing. It's a bit high level, okay? Oxidation, there are two things. Either oxygen is gained or electrons are released. And in reduction, electrons are gained and hydrogen is gained. Okay, you understand? In oxidation, electrons are released, oxygen is gained. In reduction, hydrogen is gained, electrons already gained, right? So this is oxidation. When it combines with O2, it's called CO2, and this is good reducing agent because it reduced O2. Right? Then N2 plus 3H2, so it combined with hydrogen, that is called a reduction, and that means it's a good oxidizing agent. Right? Now exothermic is where heat is released. Exothermic reaction where heat is released. How do you remember this? You remember that heat exits. Exo exits. Exothermic, heat is released. Endo, that means that is just the opposite of exo. So heat is gained. In endo, heat is gained. Understood? Very easy. Let's see some examples of all these reactions quickly. Right? The first reaction, PbNO3 twice plus 2Ki becomes PbI2, so I combined with Pb and K combined with NO3. So this becomes double displacement reaction. This becomes double displacement reaction. Understood how it became double displacement? Because I displaced NO3 and NO3 displaced I, and that is how it became double displacement. Now, these three are very important reactions, okay? CaO, you have calcium oxide or quicklime we call it. You add water in it and lots of fumes get out. So that is, the product is CaOH twice plus heat is released. So it's an exothermic reaction. Okay, then we have CaOH twice. Now this CaOH twice that we made, we add another carbon dioxide. This is called slaked lime or lime water. Slaked lime or lime water is calcium hydroxide. Okay. If you combine CaOH twice with CO2, that becomes, now this CO2 replaces OH twice. It replaces OH twice. So it becomes CO3 plus H2O and limestone is made. That means lime water becomes a little milky. That's why we call it limestone. Right? And this becomes displacement reaction. Why? Because what happened? See, this CO2 displaced H2. It was like, hut, bhag ja yahan se. So CO2 displaced OH twice, and that is how it is a displacement reaction. Now we have this CaCO3, but the point is this CaCO3, it is insoluble. Okay, this is insoluble. Now what we do? We combine this CaCO3 with carbon dioxide and water. Now what became is calcium hydrogen carbonate. This is calcium hydrogen carbonate. So now this CaHCO3 twice is actually soluble. So we started with simple CaO, we combined that with water. Wait, let me clear this all out. What we did, we started with calcium oxide, we combined that with water, that became calcium hydroxide, and that is what? That is an exothermic reaction, heat is produced, and this is called slaked lime or lime water. When lime water is again added with CO2, it becomes calcium carbonate, that is our limestone, and this calcium carbonate is milky in nature, correct? Then this calcium carbonate combined with carbon dioxide and water, it becomes calcium hydrogen carbonate, and this prolonged passage of CO2 make milkiness disappear. So this milkiness became made it insoluble, but prolonged exposure of carbon dioxide made it soluble, or the milkiness even got disappeared. Okay, the last we have PbNO3 twice. So there is single reactant. See, it got broken into PbO plus 4NO2 plus O2. PbNO3, the N was like, I'm going, I don't want to stay with you guys. So PbNO3 twice, it broke into PbO. O was like, no, I will stay with lead. So lead oxide, 4NO2 plus O2. Now PbO, this PbO is yellow in color and NO2 is reddish brown in color. And since there is only one reactant, so many products, this is called decomposition reaction. Right, we have one more page of reactions, because this video I told you we will do the whole chapter. So all the reactions we are going to do in this chapter. So simple, 2AgCl converted into Ag plus Cl2. Again, this is also a decomposition reaction, right? Next we have, this is the same, Cl and Br are of same family, that means of the same column of the periodic table. So they show the same properties almost. 2AgBr, again 2Ag plus Br2. So they are used in white and black photography because this happens due to sunlight. This is the symbol of heat or sunlight. So when you keep AgCl in sunlight, it breaks into Ag and Cl2, and that is why these are used in black and white photography. Okay, now iron plus CuSO4, iron displaces the copper out and it becomes FeSO4 plus copper. Now copper, CuSO4 was blue in color, now FeSO4 is green in color. Hey, Wait, I told you something wrong then here, right? Oh, that I confused alone copper with. Yeah, here CuSO4 is blue and it got converted into FeSO4, that is green. I told brown, right? I got confused between B and B. That is a mistake on my part. So sorry, so sorry. Okay, let's just do this quickly. Where we are? Yes, here we are. Okay, so copper sulfate is blue in color. When we add iron, the iron displaces copper out. It becomes FeSO4, which is green in color. That is, now this is what? This is displacement reaction. That is displacement reaction. Understood? Then we have Na2SO4 plus BaCl2. Again, a very famous reaction. Precipitation reaction. Why? Why is this called precipitation reaction? You comment down. This is slide number 13. This is slide number 13. And you comment down why we get a precipitate. Why we get a precipitate, or which reaction is this? Displacement, double displacement, decomposition, combination. Which reaction is this? Your question is, which reaction is this? Slide number 13. You have to write the answers like slide number 13, this reaction. Okay. Now Cu combined with O2. Copper combined with oxygen make copper oxide. Now Cu is brown in color and CuO is black in color because copper, brown color of copper oxidizes with oxygen, right? So this is an oxidation reaction. Makes sense? Oxygen is added. Then we have iron plus 3O2 plus water. Now there are we have lots of gates made of iron, right? And we know if we keep it so much in the air, light, sunlight, water, it gets rusticated. It gets rust on it. So that iron, when it combines with oxygen or water, it gets rust. And what is the formula of rust? Is this 2Fe2O3, Fe2O3 dot XH2O. X can be any whole number. So what is the formula of rust? Fe2O3 dot XH2O. Done? Okay, just a few things are left. What is corrosion? We know the process of slowly degradation of the metals due to the attack of air, moisture, acid that we just studied, right? The rust gets on the iron, that is called corrosion because of the exposure of iron to air, moisture, sunlight and all those stuff on the surface of metal is called corrosion. Or corrosion is a natural process which converts refined metal to oxide. So iron is converted into iron oxide. Its oxide and hydroxide or sulfide can also be formed, right? Copper reacts with moist carbon dioxide and gets converted into copper carbonate. So this copper reacts with moist carbon dioxide and H2O plus H2O. It becomes CuCO3, that is copper carbonate. Understood? Silver article turns black when exposed to air due to the formation of silver sulfide. Okay? True? Now, what are the methods to prevent it? Because we obviously don't want our gates, our furniture to get corroded, right? So, we can either do a coating of a preventive substance on it. We can do the coating of painting and we can do the galvanization. Galvanization is the coating of zinc over the metal, over that metal surface, right? So, you can use that. Next, we have rancidity. Rancidity, see, corrosion is the process of metal going bad. Rancidity is the process of our food going bad. See, whenever you leave your food out for some time, due to the exposure of oxygen, air and all the bacteria, there is a foul smell in that food, right? So that is called rancidity. The process of what is actually happening? Oxidation. Whenever our food has oils, right? So oils oxidizes and they give a foul smell. The process of oxidation of oils and fats present in the food material which leads to the formation of undesirable and often foul smelling compounds. This process negatively affects the taste, the smell, the safety of the food. We obviously know food gets really bad when it gets rancid. So what is happening? The oil inside the food is getting oxidized, right? So what should we do? First, we can add antioxidants which will prevent the oxidation. We can add sodium bicarbonate, Na2CO3 is a very good antioxidant. Then storing in airtight containers just remove the excess of oxygen, it won't get oxidized. Then refrigeration, we prevent the molecules to get reacted with the oxygen, right? And then flushing with nitrogen, we all know when we open a packet of Lay's, a flush of air gets out, right? That air is actually nitrogen because it prevents the food to getting rancid. And that is the revision of the whole chapter, chemical reactions and equation. You have to love it, and I hope you all enjoyed it as much as I do. It's been 35 minutes. Let's just do 2-3 questions, and I'll give you 2-3 questions as homework that you have to answer in the comment section, right? Now, a dilute ferrous sulfate solution was gradually added to the beaker. There is a solution ferrous sulfate, Fe2SO4, is gradually added to the beaker containing artificial permanganate, that is KMnO4. Now, the light purple color of the solution fades and finally disappears. Which of the following is the correct explanation of the observation? Now, if you have watched the one shot, if you have studied, you know that KMnO4 is an oxidizing agent. It is an oxidizing agent, so it oxidizes FeSO4. So what is the true? A part is the true option. KMnO4 is an oxidizing agent. It oxidizes FeSO4. Done. Next, we have, which one of the following reactions is categorized as thermal decomposition reaction? Which of these is a thermal decomposition reaction? Okay, actually, let's see all the correct. The correct option is actually CaCO3. I'm so sorry, I did it before telling you the answer. Okay, so CaCO3, when it converts into CaO plus CO2. Now, whenever carbon dioxide is released, there will be heat. And if heat is there, it's called thermal decomposition, right? And see, it came in CBSE 2021 as well. So, all the other, see, these 3 reactions, what are these? So, H2O converts into hydrogen and oxygen, we know it is electrolytic decomposition. The AgBr and AgCl, we know it is photochemical decomposition. Why? Because it happens in the presence of sunlight. So for this, the correct example of thermal decomposition is this one. Why? Because CO2 is released. That is why it is a example of thermal decomposition. Whenever CO2 is released, you will have heat with it. What am I doing? Heat with it, and that is why it is an example of thermal decomposition. Okay. Next, we have a assertion reason question. Burning of natural gas is an endothermic process. Do you know what endothermic is? When heat is gained. And how come burning leads to gain of heat? Okay, think about it. Then methane gas combines with oxygen. Methane gas is CH4. It combines with oxygen to produce carbon dioxide and water. Carbon dioxide and water. So is it true or not? You tell me. This is your homework. You tell me the right answer. Answer will be in the comments. Whoever is watching, write down slide number 20. Slide number 20, and what is the answer? A, B, C, D. Which one is the correct option? I have the correct option here, but I won't tell you, so we will skip this slide here. Okay. This is the last question. A student took sodium sulfate solution in a test tube and added barium chloride. The very famous question came in CBSE 2021 again. What is this? Na. The student took what? Sodium sulfate, Na2SO4 plus it had barium chloride, so BaCl2, and he observed that an insoluble substance, that means precipitation happens, has formed, and the color and the molecular formula of the insoluble substance is. Now we know that this is a very famous, so it becomes BaSO4 plus 2NaCl. Right. So, which is the precipitate? BaSO4 is the precipitate. BaSO4 is of white color, my beta. BaSO4 is white color. So, B option is the correct option for all of you. We are done with this first chapter. We quickly revised the whole chapter in just, I will say, 30 minutes. Okay. Because that is what we do. I want to give all the information I have in my heart to you, so sometimes it takes 7 to 8 minutes extra. Okay, so don't mind. That is it for this video. I'll meet you in the next one. Subscribe the channel because we are going to come with lots of videos, lots of questions, lots of live sessions for you guys, and I'll meet you in the live sessions. Bye.